Hi, and welcome to our CIS 117 Week 7 live lecture and hangout. This will be our last live lecture for this 8-week short course. And so I want to remind everybody to check the dates for the final exam. Make sure that you don't miss it, get it done. And also remember that we're a couple days shorter in the last week of the term than you're used to. So make sure you also remember to submit your Week 7 work by that time, including if you plan to do the extra credit assignment. There's a choice of 2. You can pick one of the 2. Make sure you get those in as well. I highly recommend them. They're fun. They're very worthwhile, and you can always use a couple extra points. Remember, the difference of a point can be the difference of a letter grade in this class, because I don't fudge the grade book to resolve cliffhangers. So fractional points I will give you. I will round those up in your favor, but anything that is more than a point stretch is a miss, and it's too late after the fact to come back and do anything about it. So word to the wise. All right, so let's jump right in with some parallel exercises. And so our parallel exercise uses the current chapter's exercises from the textbook as usual. And let's start out with some of the stuff from TAL. And one of the first things we're going to do here is a string function to shift things to uppercase. So list the item numbers and description for all items. The description should appear in uppercase letters. Okay, so let's use TAL. And then let's start with select star. Oh, Jason's here. Welcome, Jason.
Hey there.
Hi. So I had just started the recording, and we're jumping into our very first parallel exercise. And let me just recap. So that parallel exercise is from, here we go, it's from TAL, and it uses a string function to shift the output to all uppercase. We're going to list the item number and description for all items. The description should appear in uppercase letters. Okay, so if we start off with a select star as usual, and let's make that from items and get that running. Okay, so take a look. Item maybe? Item ID. No, select star from items. Yeah, that's right. Use TAL. It's TAL online. Let's take a look here. TAL, tables, item. Okay, and we want to take that and make the title into uppercase. And that's not TAL. This is using my other data set that parallels TAL number 1. Okay, so let's do the parallel. I'll work it out on the fly. So we want to take let's get the item number and the description and pare it down, but we'd like that description now to be, let's say, in all uppercase. And so we can take the string function upper and apply that here, and notice that these are all mixed case now, but when I run and refresh, they're now in all uppercase. Okay, so that's our first parallel question. But Jason, I always like to start with any questions that the students have for me. Did you have anything from the week 6 or week 7 work that you wanted to look at?
Unfortunately, I haven't had a chance to read the chapter 8 yet, so I'm not there. But not really from last week. I guess my only question is if you have any other resources you recommend for practicing besides the stuff that's in the book, the exercises in the book. Is there any other resource you recommend for practicing the different, I guess, doing queries and views and all that?
Oh yeah, there are tons of tutorials on the web. There are Lynda classes, lynda.com, which you have access to for free as a UC Santa Barbara, or excuse me, Cal State. Okay, let me work my way into the community
One more
college
time.
system. The Santa Barbara City College system. We have a contract with Lynda, and so you can take advantage of their courseware for free if you don't mind shelling out $20 or $30. Udemy has some nice courses, Udemy,
Okay.
and some good stuff. But boy, I'll tell you what, you can pick up some of the trade books or a used textbook that's just a year or two out of date at a pretty good price. So, buying a used book through Amazon booksellers that has some exercises to work through. At this point, you should actually have, as far as basic multi-table queries and joins, you should have a pretty good grounding. What I would recommend, if this stuff really fascinates you and you want to take it to the next level, two things. One is I'm going to point you tonight toward two topics that we're not going to have more than this week to explore. So we're just going to barely scratch the surface. And those are stored procedures and triggers, and I'm going to give you my little mini lecture in a minute about why those are so powerful. But essentially, what stored procedures are going to do for you is they're going to take a lot of the programmability that you could put in an application code and puts it right there in the database for you to give specific calculations and specific behaviors to your data. And triggers are all the nice things that you wish would automatically happen every time somebody does something to your database. So if you wished every time somebody updated a record that this would also happen, or every time they deleted this record, this would also happen. Or maybe you want to safety net something. So if we're running a bank, do we allow customers to cancel their accounts? Of course we do. Do we allow them to cancel their accounts when they have a non-zero balance? No. As a fiduciary, if we have their money, we have to give it back to them. That's the law. And the other thing is, if they owe us money, no, we don't allow you to cancel your account when you owe us money. That's a credit account. You have to pay it off. We may sell it and send it to collections or something like that. But no, we don't just cancel it. You wouldn't that be nice? I keep trying to write checks for a negative amount to increase my bank balance, but so far it hasn't worked. And so those kinds of checks, yes, you can build them into the application, but isn't it nice if you build it into the database that every application downstream of the database uses, then all that creamy, golden, delicious goodness happens auto-magically. And you don't have to worry about whether some bonehead programmer got it right, when we know that all the real geniuses work in the database part of it. Now, for your information, yeah, I say exactly the opposite thing when I'm in my programming classes that I teach. So I am patronizing you, but what the heck, I don't have tenure yet, right? So there you are.
Fair enough.
Okay. Other questions?
I think that's it. I did find some of the last assignment a little difficult, just coming up with those queries, but I rewatched the video from last week that you did the parallel programs. And I think I was able to get a better understanding by doing that.
Some of the queries, particularly the queries that are nested, you got nested subqueries, and where we start to see this nested subqueries reaching out, as it were. You have to work your way from the inside out rather than outside in for it really to work or connect. And when we start combining aggregation with it, it can get pretty hairy. And I'll tell you, the saving grace a lot of times on complexity is create yourself a view. Even if it's in your DBA sandbox, once you create the view, and then you can build queries and maybe nested subqueries on it, all of a sudden you go, okay, on this view it was really easy to figure it out. Then all you have to do is say, well, that view is nothing but a query. So every query against that view is a query wrapped in a query. And at that point you can then, if you want to unravel the complexity and put it into a single nested query, or multi-table joins or unions or whatever has to happen, it becomes a lot simpler. So always break it down into the simpler pieces and do it a bite at a time. That's one of the reasons that I tend to start every query with select star. Get all the data and all the fields out there, and then start trimming it down. So the other thing I'm going to take this opportunity to emphasize is I will have students that will come up with a query, and it will generate the correct result set, and I will mark them off for it. And they'll say, well, but it generated the correct result set. And I'll point out that on this particular data, that query worked. But as soon as one of the places we see this is on wildcard queries. So select star from item where description. Nope. Select star from item where, and what do we got for a field here? Well, let's just start this. Okay. Where description, like, and let's put in wood. All right. So you notice that we have two things that are wood block sets. Okay. And you say, well, that's great. I wanted all the wood. Well, the problem with that is, it's really easy to get sloppy. That works for this data set. Let's modify the data set so that we get something that we should not have gotten back. So I'm going to edit the top 200 rows. And I'm going to come in here under the description. And this is not just a classic railway set. This is if I can do it. All thumbs tonight. It's classic railway set by Elwood. Okay. So now we go back to here and we run this. And now we didn't want to get things that ended with wood or had wood in them. We only want things that started with wood. And so that's really the wild card we wanted. And so getting sloppy because it works with your test data set. A lot of times we will have a sandbox or sample data set in the DBA group that we're working with, and it is usually an older system, a lot smaller system than the real production system, and so we're working with a much truncated set of data, and we test our stuff in it. If you don't watch stuff like that, we don't catch the real world cases until we let our code out into the real world, and then we start to get errors because we didn't think it through. So you can generate the correct result set with an incorrect set of query logic if you just happen to get dumb lucky. So we need to think really intentionally about the data. So anyway, that's my DBA tale from the dark side and terror story for the evening is make sure that you your logic is correct and complete, and not just the fact that it worked for that particular data set. So, all right, word to the wise. All right, let's pick it up with number 2, unless you have other questions. Anything comes up as we're looking at it you'd like to see, just let me know.
Okay.
So let's take a look here. We want to list the customer number, name, and balance for all customers. The balance should be rounded to the nearest dollar. And this one, because it's balances, I think I do need to go over and use the CIS 17 database. And let's start again with select star from items. Yeah. Okay. So there's all my great stuff from items. And what we're looking to do is we want to pare this down. And we wanted to demonstrate let me double check this for just 1 second. Let me see what our HCIT assignment was, make sure I've grabbed the right data set. I saw something that bothered me. So let me just come over here to .117 files for week 7 and take a look at the HCIT instructions and make sure it truly is parallel. So this is your actual set. So this one's grabbing lab code, lab name, charge for a calculated field based on a 35% discount. Yeah, it's a little bit different. Okay, so a parallel problem for that would actually be, let me go to my other set of notes here. Okay. So we want to list the item ID, title number, sale price for all items. The sale price should be calculated based on it, and I'm saying in this example, parallel 25% discount price. Name the display field for the calculated field, sale price, and use the format function to format that field as US currency. And there's a reference on that there for formatting if we haven't done currency before. I think we've already done currency several times in this class, so that should be familiar. So, all right, back up in here and let's see here. We got star from items and we want to pare that down. We only want the item ID, the artist, the title. We want to get the unit price, and we're going to do something to it and name it sale price. Missed a comma. Okay, and so what we'd like to do with that thing we're going to call sale price is we'd like to format that unit price. And as we're formatting it, let's multiply it by 0.75, so a 25% discount. And then let's cast that as currency in English US currency units as opposed to won or baht or yen, and give that a shot. Of course, it helps to spell format correctly. There we go. And there we go. So, and just if you want to sanity check that for a moment, compare that to the original unit price. Always a good idea to sanity check your work. And that eyeballing it look about 3/4. So, you know, this is about $16. So 3/4 of that, $12. Yeah, that looks about right. So that sanity checks nicely. Okay, and then drop it back off. And there's just the selected fields. Good. All right. So let's take a look at our number 3 problem. Company's running a promotion that is valid for up to 20 days after an order is placed. Okay, so we got a timer from the date. So we're going to do some date arithmetic there. From the date that the order is placed plus 20 in days. And we want to list the ID, order ID, customer first and last name, the order date, and the promotion date for each order. The promotion date is 20 days after the order was placed. Refer to the following reference regarding T-SQL data arithmetic. Okay. And there's a little hint there that I put in. So let's take a look at how we build that. So let's start with select star from customers, orders, and customers. And we need to join those. So how do we join customers and orders? Probably on customer ID. So orders.customer ID is going to equal customer.customer ID. And there's our nice big join of everything. So that looks good. Nulls for some faxes, that's all right. Doesn't bother me if the customer doesn't have a fax machine. And then what do we need to do here? Okay, first off, we didn't want everything. We wanted the order ID, but I can't just say order ID, or can I? Is that ambiguous? No, that's not ambiguous. So I don't have to fully qualify that because order ID is not in customers. So I need the order ID, I need the customer ID, and that is going to be ambiguous because it appears in both tables. So let's get the one from customers. Is more authoritative for the customer ID. And let's see, what else do we want? We want the customer first name. That only appears in one table. I don't need to qualify it. Customer last name only appears in one table. Don't have to qualify it. The order date. And then I'm going to do something else. I want order date again as promotion date. Let me move the talking heads out of the way for just a moment. And right now, order date is in here twice. The two are going to be identical. But what I need to do is I need to add 20 to that day-wise, okay? So what do I need to do my date arithmetic? I need to take this thing, let's wrap it up in parentheses, and we need the date add function. And in order to take the order date and add 20 days to it, we need to say, format of that function is day units, 20 of them, to order date. And there we go. And let's sanity check that. So is it true that if this is October 23rd of 2012, that 20 days later is about the middle of November? Yeah, okay, so that looks to be about right. Neat. All right. Next problem. Oh, it doesn't wrap automatically. Well, I'll just bring it in this way. Okay. So, item 4, write a T-SQL procedure. Now this is a procedure. This is the first time we've created a procedure. A procedure is a query that usually we make a procedure able to accept replaceable parameters, so it makes them more flexible. And we put the procedure in the database, and then we can call we call that a stored procedure. And when they're user stored procedures, we call them USPs. And I tend to have the habit of using the naming convention for user provided stored procedures as USP underscore. You don't have to do that, but it's a nice thing to do. And we're going to create a stored procedure that does this thing. What thing is it going to do? It's going to obtain the artist and the title of artist whose name is like the value stored in artist. Okay, so this makes it very, very flexible. To reuse this, all we have to do is type in part of the artist's name and whatever that matches. So I want to use a wildcard on either end if I want it to be any part of the user's name or the artist's name. And so once that's done, then I want to create it as a procedure, a lot like creating a view. And then to execute it, all I have to do is call the exec command. One of the really beneficial things about this is when you have complex procedures, and you want to make sure they're always done the right way or the same way, because some procedures might update data or delete or insert data. We put them in the database. Then we publish a list of those called an API to our programmers, and then any programmer that is using that database in their application, rather than having them write code, which might differ and they might have bugs in it, they call our stored procedure. What's really brilliant about that is, let's say that down the line in the future, we come up with a more efficient way of doing it, or let's say we change our underlying data model and so that the table structure is a little bit different. If we update our stored procedures and it still uses the same number and type of parameters, then it will work with our new data model or modified data model, and their application will still work without having to be updated or revised, or at least we can minimize the impact on the different companies or programmers that are coding against our database. So this is an extraordinarily useful thing to do. All right, so let's start by building just the query. So we want to select star from items. Okay, so there's star from items. Now let's add a where clause. Where artist like, and it's going to be, let's take a specific example. Let's get any artist that has UGGL anywhere in their name to start with. And let's go ahead and order that by artist and title. Okay. Run that, and I have all the works of Burt Ruggles. Lovely. Okay, now I need to generalize this a little bit. And so what I want to do is I want to replace that UGGL. I need to break that out and say the wildcard stuck together, concatenated to some variable, and variables in SQL code, Transact SQL code, start with the @ sign. At artist, and then stuck together with that wildcard. And so now all I have to do is provide a replacement value for what the artist is going to be, and that will work. Okay. Okay. So what I need to do here is, before my select, I need to declare this and say artist is a varchar of 50. Why did I pick that particular value? Well, if I'm thinking ahead, if I go over into the item table, oh, that's TAL. Let's take a look at 117DB, tables, items, columns, and if I look at what artist was, it's a varchar 50. So making the variable varchar 50 means it won't ever waste any space, but I'll never be caught short either. Okay, so even if somebody types the entire artist name and it's all 50 characters long, it will match, it will work. Okay, so that's kind of why I chose that. Okay, as, and now that I've got that built out, let's see if we can create it as a procedure. So let's create procedure, and we have to give it a name. And let's call this procedure user stored procedure disp all by. So it'll be display all by artist. And let's run that and see if that works. Completed successfully. So if that works successfully, now let's test it. So what if I were to say exec USP display all by, and now I need to put in a value for artist. What if I said UGGL? And let's highlight that and execute it. There it is. What if I said where artist equals empty string? What would that do? Because it begins with anything, ends with anything, and the empty string doesn't count for anything. It's giving me all of them. So what about, let's see, is something here that will get me two together? How about just all the artists that have U in their names? So sanity check that. It should be Umami, Uber Nerds, and Ruggles. Pretty cool. So this is actually a very useful stored procedure. Can use that very quickly. So when you go to if you've ever been in the game section at Best Buy and you ask them if they got a certain game in stock and you don't really remember, the whole title of the game, you give them enough to type a few characters. It's probably calling a procedure very much like this that's linked in with their application, and there are your results. Okay, great. So we've created that procedure. In order to drop the procedure, we do exactly as you would expect, just like we've done with other objects and dropped views. You just drop the USP by name, and away it goes. Okay, so let's do another one of those. Let's take a look at parallel exercise 5. So 5 says, write a T-SQL procedure to obtain the order date, customer ID, customer first name for the order whose number currently is stored in the @order ID variable. Name your procedure, USP disp orders, so display orders. For example, a value of 89 and order ID should return Rashad Holbrook's order of 2013, January 20. Issue the command which follows in order to demonstrate that it's working correctly. Okay, so let's see how we build up to that specification. So let's see. We need a select star from, and we're going to need orders, and we're going to need customers if we want to know who ordered what. And so again, going back to how we join those are going to join on custom on customer ID. All right, so there's our basic join. With the join working, then we need to pare this down, and we only want the order date and the customer ID, but customer ID is ambiguous, so let's pull it out of, let's pull it out of orders this time. And we want the customer first name and the customer last name. Let's try that, and there they are. And we need to add something to the where clause. So we need to be able to filter this, and so where orders dot order, let's see, and right, and orders dot order ID equals something. Now we could put a literal in here to test it momentarily. I think there's one down there that matches that. Does that work? It doesn't convert for us, so let's see here. See if I formatted the string correctly to be converted to date format.
When that is how it's formatted, what's the reason behind that?
It's because of the date type. Depends on how the date type is declared and the conversions that are implicit.
Okay.
So what we should do is we should cast it to date specifically. And I'm just don't recall it. So I was trying to be lazy and see if it would auto convert it as string for us. So, but what we're going to do, let's go ahead and jump ahead to that. So what we're going to do is we're going to change this date so that the date is equal to, oh, it's not the date we want anyway, is it? It's the order ID. Duh. Okay. Sorry. Senior moment here. So there's our result. We want the order ID. So let's grab order ID equals 8. So here's our literal. Oh goodness, what did I do wrong? That should have been a no-brainer. Oh, that's customer ID. It's order ID that we wanted, and I didn't show the order ID. So let's temporarily show the order ID here. Okay, so let's grab order ID 19. All right, so there's the order ID 19. Now what we want to do is we want to generalize this so it will work with a replaceable parameter, a variable. And so let's call that order ID. And then let's go ahead and turn this into a stored procedure. So let's create procedure USP disp orders at order ID, and that's going to be an integer type as, and let's see if we can go ahead and create that, and that created correctly. So now we should be able to say exec USP display orders and at order ID equals 89. And so now all we have to do is to display a particular order, call that function. And so again, that's a really handy thing to be able to pull from an application, a smartphone app, a thick client, or a web client. And so if you think about it, you probably in business have all three platforms that you're supporting. You probably have your internal corporate customers that are using a local application that has been written for them that they're running on their workstation. You probably have client-facing web servers that are running through a web page, and you probably have a smartphone app for the Apple or Android store or both. And so the more code that you put here in the database, the less code that has to go in and be duplicated and possibly duplicated incorrectly in those three different platforms. So it's just smart programming, build it once, use it many places, and keep it central. The other thing about code that's central, that's less to deploy. So it means that the download time and the size of the download for your Android smartphone, where space still is kind of limited, it takes up has a smaller footprint. It downloads quicker. More people will actually download and use it when that's the case. And your web programmers can leverage that logic as well, so they can focus on the user experience and the markup in presenting an attractive page, which is far more important a lot of times than the details of the application logic when it comes to your web customers. So there you go. All right, good enough. On to the next. And I noticed that Priyanka has joined us. Priyanka, I wanted to make sure that if you had any questions this week, we answered those before we work any more parallel questions.
No, everything is fine.
I think you said no, but you broke up a little bit.
Yeah, I said that everything is fine up to now.
Okay.
Everything is
All right. Well, if anything occurs to you that you want to see explored further, let me know, because again, the live lecture hangout time is really student time, so I'm more interested in answering any questions you have. But failing that, we'll go ahead and run some parallel questions for this week's exercises.
Just a second, John. Like for the last problem, like you were entering the order ID and like it was not accepting. I'm just talking about some of the other problems. Like in most of the problems where like you specified that we require casting, like when there is date for a specific date parameter, casting is required. But in some other problems, like no casting was required. Like is it like I'm very confused, like in exams, like what should be preferred, like it is it good to use casting tool, like
And
the
unless I am specifically testing you on the cast function, I will accept it with or without the cast.
Mhm,
The reason that cast is good is that, although we are teaching SQL Server this term, and SQL Server is a marvelous tool, but
mhm,
SQL Server is not the entire market. And when you start getting into Oracle and
mhm,
Postgres and MySQL, you're going to find that they are not always as generous with implicitly casting for you. You have to know, and how to troubleshoot and determine that the cast is the problem. It didn't implicitly convert for you. The
mhm,
other thing that we can set is the collation in SQL Server. If we change the collation model, we can set it so that it is case sensitive. Um, Most modern databases are case sensitive, and so a lot of our coding has been a little bit lazy because we haven't worried about whether it was an exact upper and lower case match. And sometimes some databases give you a choice, but these are things that I want you to be aware of so that you're ahead of the game in the rest of your career. The other thing that to keep in mind is that the fact that the database implicitly casts or will do type conversions for you, such as SQL Server, is not always a good thing, because if you're not aware that it's doing that conversion, it can lead you into some poor assumptions logically, and you can end up again creating query code that happens to work for a test data set but returns things you didn't intend on a production data set, and so the code is the query is not actually correct. It has gaps, or it has inclusions you don't intend in the logic. Let's see what else. Uh,
I think yeah, I got
yeah. It's just kind of a best practice thing. Oh, we should also talk about, think about this. If I say I want, so I'm going to select something from something where x equals y. Now, if x is the expression that I'm sending, and it happens to be a string, and it really should have been a num, right? And so it has to convert the literal expression that I sent in. It only does that one time, and once it's converted, it compares that with all the values on all the rows. Think about a situation where x is equal to something, and let's say that this thing, which is coming from the query side, has to be converted each time for each row. And that's, let's say you have 10 million rows. That's 10 million conversions that have to be done dynamically as the query is running. Now, every string conversion takes a certain number of CPU cycles. Now, CPUs run very fast. How fast? Typical modern CPU may be running at 3.4 gigahertz, right? So it's really very fast. We think of that in terms of being a fraction of a second. It still adds up because your program running on a scaled database, an enterprise class database, may be serving 10,000 concurrent users, or many tens of thousands of queries per minute, per second, possibly, if it's really big data. And if you're doing that many conversions of each row, then the efficiency of your query really starts to matter. And so by developing good habits of making sure you don't cause conversions of data to have to occur, especially they call them string searches, that kind of thing, it would be, it's much more efficient. And so when you start talking about big data where performance is just paramount, we have to take those kind of efficiencies into consideration. So, so in some cases, it really does matter. Of course, I will be the first to concede, the first order business is just make sure that the logic is correct and that your query works reliably. Because if that doesn't happen, it doesn't matter how quickly and efficiently you give me the wrong answer, right? So, we got to keep our priorities straight. But once you have correctness, we need to start thinking: is there a faster or better way to do it? One of the things you'll learn in intermediate and advanced SQL classes is there are commands that you can give the database. One of them is like describe plan. And if you describe plan on a given query, it will actually run through and give you a report of how the query optimizer would work for the database that you have with the tables you have now. So if there are primary foreign key relationships, the query optimizer will always choose those first. If there are not, it will, and you leave it to a natural join, and the natural join could use multiple columns, it will choose to join on columns that both have indexes. If both don't have an index, it will choose the common columns where at least one has an index. And after that, it will do the best it can, which is really a table scan. It's the worst possible performance situation. And by looking at that on a sample database, most data, most application development groups in corporate world and in the production world, they have small sample databases that are built from their production data on older, slower hardware that they can use for development. They call it a sandbox. And so you can run describe plan, find out that, boy, this query would run so much better if we built these extra indexes. And so do you always build those indexes? The answer is no, and here's why. How often are you going to run that query? If that query is run once a year and it doesn't really matter how fast it runs, it can run overnight if it has to, you're not going to go ahead and waste the resource. Indexes cost time to maintain, because once you build them, every time the database changes, the index has to be updated. And if you want real efficiency, what you should do is you can wire your indexes into memory so that they aren't written out just to disk, but they're, disk is slow, things in RAM are fast. But if you start taking large indexes and holding them in memory, which is one of the settings that the database analyst, the advanced database analyst can manipulate, you start locking those into memory. Now you're starting to eat a very scarce, relatively speaking, commodity, because even if you have a lot of RAM, you do that with a few objects, and pretty soon, even though the performance it affords you is great, the cost is also great. You have less free memory to do other things with. And so these are the kinds of things that you'll explore either later in your career or when you take an intermediate or advanced database class or a database system administration class, or when you start studying for one of the certification exams for Oracle or SQL Server or MySQL or any of the major databases. So, okay, probably beat that to death, but it's good to talk about. These are useful things. All right, let's see. I should be able to tell by just refreshing the stored procedures that we've built to see where we left off. Um, okay, and have I refreshed that? Let's refresh it. Okay, so we got through display orders. Okay, what about, so everything we've done in a stored procedure so far has been a select statement. What about changing data, updating data? Can we do that? Sure. So a parallel for exercise number 7 says write a T-SQL procedure to change the date of the order whose number, you give me the number and I will update the date for you. Okay, and so we're going to call that USP update order date, and we need to just change the date. So let's take a look at how we would do that. Always start off, even on your updates and especially your deletes, we're going to start with a select query. So let's see here. Select star from orders. There it is. And so what we're interested in is changing the order date. And we want to do that for a particular order ID. So let's select just the order date. Let's start with the order ID and the order date. And we're going to do this by order ID. Order ID, and let's say 29. Okay, so there's the select. Okay, now that we've got the select working, what we want to do is we want to change that to an update. So instead of select, we're going to update orders, and we're going to set order date equals something, where order ID equals something else. Okay, and so let's see here. What do we want to do? We want to generalize this. So one parameter is going to be order date. Set the order date to order date, where order ID equals the second parameter, order ID. Okay, so we need to go ahead and create this as a procedure. User stored procedure, update, order, date, and then we need order date as a parameter, and that's going to be an integer, and we need, oh, order date is not, order date is going to be a date, and we need, let's specify them in the other order around. Order ID is going to be an integer. And keyword as. And let's see if that works correctly. Okay, that compiled, so let's go ahead and test it. And how should we test it? Let's say select star from orders where order ID equals 999. Underscore ID equals 999. Do I have one in there? I don't know. No, there's not one in there right now. So let's go ahead and put one in there. So and let's put in a order ID 999, and we'll do it again for customer 9. And let's leave the order date as null, and the ship date as null. Let's see, can I leave an order date null? Will that allow us? Why are you upset? Oh, that's been changed. I don't care. Okay. Not committed, null, not allowed, in order date. Okay, so it makes us put an order date in. So let's put in a patently incorrect order date. How about 1941 of 10/3? So we blew the year. Okay. So clearly we didn't really order it in 1941. There should have been some data validation on that that entry. Something was blown. Now let's see if we can fix it. So here's the select. Is that now running? Yes, it is. So now let's see if we can use our stored procedure to change it. And let's say exec USP update order date, and let's set order date equals, and we'll set it to today's date. So that should be 2016 dash, and I'm cheating again, right? Because I'm throwing it in as a string, right? I'm being lazy. So I'll admit it. Let's make it 10-03. And order ID equals 999. And since we can do so, let's display it again rather than by running the select star again. Let's use our other stored procedure we already created. Did I not create a display orders? Did I delete it? Yeah, I've got display orders in there. There it is. I can see it. And that takes order ID of 999. Okay, so one should update it and the other one should display it. And there it is. So now it's been fixed. Right? Cool. All right. So at some point I ought to probably come back and kill that that order ID. And maybe that's coming up next. So let's take a look. Yep, that's what's next. Okay, so if we can select with stored procedures, we can update. The only thing left there is we can create, insert, update. Got to be able to delete. So let's see if we can create a delete orders, and delete orders is going to delete based on the order ID that is input. And so let's again, as always, start with a select. So select star from orders where order ID equals 999. That's what we just put in, right? Okay, so run that one. And there it is. That all works. And let's break it up. All right, so now we want to delete. Okay, so instead of select star, I want to delete from orders where order ID equals 999. And I could even, given the skills that we've learned so far, test this. We could say begin tran, and then if we go ahead and run this, and then instead of committing, we say rollback. And before we do the rollback, let's say select star from orders where order ID equals 999. Let's start by running the first part. And it should be deleted. And now if we run the second part, there's none. And now if we close the transaction with the rollback, and now if we select it, it should have come back again. Aha, the safe way to test a delete. Love it. Okay, so I'm done with that piece. Now what I need to do is I need to take and change this from a hard-coded delete statement into a parameterized stored procedure. So I don't want to do it where the order ID is equal to 999. I want to be able to replace that parameter. So let's say where it's equal to order at order ID. And now let's come back and create the procedure. So let's create procedure, user stored procedure, DEL, orders at order ID as an integer, as the following, and give it a shot. And now that that exists, let's try it. Exec USP delete orders at order ID equals 999. Run it. Bam, says it's gone. Let's see if it's really gone. So let's exec USP disp orders at order ID equals 999. Does it exist? Survey says no, it does not exist any longer. All gone. Sweet. All right. So it is 8:30, so we've used our time. I want to just show you a couple other things that I'll be happy to answer questions about. And you're going to see that I think the current week's assignment, if I recall correctly, I've given 12 questions. I'm going to grade it out of 10 because there's a couple here that are pretty tough. We can see how useful the stored procedures are. And we can get more and more sophisticated with those. But there's one other thing I really wanted to expose folks to, and that is the idea of a cursor. So up until now, most of our result sets have been pretty simple and fairly short. Occasionally, we are going to have a need to go and grab a whole bunch of data, and the results may be non-trivial. And moreover, we may be doing some additional processing at the application level with the results that we get back. And we may want to have the database buffer those results. So what we can do in a result set is we can open up when we're working in a word processor like this little I-beam here is called the cursor. It shows where I currently am in the document. I can move up and I can move down and I can select things with my cursor. The database has exactly the same idea on the result set, is you can have a cursor. So I can create a procedure that selects a bunch of stuff and then returns the result set, and then I can actually do more than standard SQL code. I can start to write programming type code, and that's where we use the extensions to pure relational SQL language. That's why Transact SQL is called Transact SQL rather than ANSI standard SQL. It's why Oracle SQL is PL SQL, programmable, programming language SQL or programmable logic SQL, is because we can extend it. So once I have a cursor open, let's see what this example is doing. So I can fetch the next row from the cursor position, and I can put it into these variables that we've learned to declare. And then I could do all kinds of fun things with them. I could format that output. I could do string manipulations on it. I can do additional logic on it. And here's where we really get away from a SQL language. SQL language up until now, we don't tell it to do how it, what it does. It's really a relational algebra. We use descriptions of sets of results that we want, and it figures it out for us. Now we're going to get into a more procedural language, which is Oracle PL SQL. What it really stands for is procedural language SQL. So it's added in that, and we're using Microsoft's dialect, which is Transact SQL, which also has these extensions. So we can put a while loop into that. And so while, and this variable, look, it has a special notation, at fetch status. So fetch status is going to tell us, are there any more rows left? If fetch status is 0, then there are more rows in the result set. I'm not at the end of the result set. So starting at the beginning of the cursored result set until I reach the end, while fetch status is 0. So as long as there's more data to process, I can do some things we hadn't seen before. I can print the output, get the next row, and put the results of that row into these variables, and again, back through the loop and print them and get them and print them and get them. And so I can write console output, or I could format data that's going to go into a report, or do all kinds of interesting things using cursors. And the interesting thing about cursor logic is I could use an application to help me drive that cursor forward or backward. I don't just have to go forward if I have a bidirectional cursor. And when I'm all done, it is very important that I close my cursor and I deallocate it, because cursors eat memory like nobody's business. That's one of the things that's going to eat resources from your database. So we got to learn to use them carefully. And this is going to be the only exposure we have on this thing called a cursor this term. It really is a topic that is a looking ahead. It's a stretch or a reach topic. You'll deal with them a lot more in future classes and in your professional life as you learn a lot more about databases and take your skills to the next level. But I always like to whet your appetite for what's more. Jason was asking me earlier, what should I study from here? Where do I learn more queries? And the answer is, well, keep studying everything we've covered so far. But if you want to see where to take it to the next level, stored procedures and cursors. And then the other thing that we haven't had a chance to explore, and I'll leave it for you, and I'll be more than happy to do a mini lecture during the week. If people have questions, I'll be happy to record additional video. Just post them for me. And that is triggers. And let's see, where do we get into triggers? Is it beyond here? Yeah, okay. So a trigger is something that happens automatically when you do something on a database. And a couple of students have mentioned this term about when they've inserted primary keys, especially when they've gotten it wrong and accidentally tried to duplicate a primary key. They've said, well, gee, Professor, isn't there a way that we could have it automatically get the next available key? Absolutely. The way we do that is with a little tool called a sequence that keeps track of the next available number. We can tell our sequences to go in, one-off number, 1, 2, 3, 4, 5. We can tell our sequences to generate numbers five integers apart, so they count 5, 10, 15, 20. However we want to generate the key number, we can do that. And then put that sequence together with a trigger. And a trigger happens every time you do something on the database. So we could create a trigger that triggers on the insert of a record for a table. And what you do with that, if you want to have a automatically generating key, unique key, is you get the next number from the sequence, and when the user or the application specifies the data to go into the database, you simply skip the primary key. And what our trigger does is it says, oh, you did an insert on this table. And I know when you do an insert on this table, I'm supposed to look, and if there's not a key provided, I'm going to get the next available key from the sequence, and I'll add that to the insert and replace that. So triggers are tremendously powerful, and you can use them to do things automatically on any kind of event. So when a record is inserted, a record is deleted, a record is updated, and you can make some pretty sophisticated and complex triggers. For example, we talked about how it would be a particularly bad idea to allow a bank to delete a user account if they don't have a zero balance. Your trigger could simply check and say, hey, you just told me to delete a user account. Before I will do that, I will execute the query that will determine if all of the balances on the user's accounts are zero, and if not, I will not delete the account. I'll roll it back, and I'll give you some sort of error code as your response. So cool stuff. Read more about them and play with them. This little taste of what's coming. Again, if you get them and you master them this week, my hat's off to you. If you don't, as I said, I think in this week's assignment, I have to go back and double check it, but I'm pretty sure that I put in 12 questions, and I'm going to grade you on a basis of 10. And so the really tough trigger question and the really tough cursor related question, if you blow them, you or just are having a tough time figuring them out or don't really quite get what it's all about, you can still get 100% on the assignment. So, and the other thing I think I mentioned earlier in the recording, I strongly recommend is you have an opportunity to do an extra credit assignment this term. It really is helpful to have a few extra points away. One of them is, well, they're both really worthwhile. I give a choice of 2 extra credit. One is a heck of a lot of fun. It works with a little bit of geospatial coordinates and GIS and visualization. We use, in that exercise, I use Google Maps as your visualizer. So it's really pretty easy to build a query that you can pass to Google Maps that will show you the spatial data or map the data. I highly recommend that, and the points are always something that students that have done the extra credit are happy that they put in the bank come grading time. So Jason, Priyanka, any questions, anything before we wrap up?
I think that does it for me for tonight.
Great. If anything comes up during the week, send the questions, and as I said, I'll be happy to either answer them, or if they need a little bit of visual explanation, I'm happy to do another video midweek. And I'll repeat the caution that I recorded at the beginning of the video, and that is, remember that our last week is a short week. Everything ends with the final exam. During the term, I open everything on Thursdays before the week actually starts, and I close them on Tuesday, more than a week later, so you get really like 12 days during the term. This is the day or the period of reckoning where I have to balance the books, so our week is a little bit short in the 8th week, and everything from week 7 is due, and your final exam is due. So please double check the final exam date, and there's also a final exam guide that you can download that I've put out in the Canvas shell. So please download that, look it over, and use all of our discussions, use each other's videos that you guys have done some excellent videos this term. I'm really impressed. Some great little lessons on things. So make use of all those in preparing for the final exam. I'm really looking forward to having as many students as possible ace that exam. It makes me very happy when you guys do well on the final.
Okay, great.
All right. Thanks again. I'm going to go ahead and end the meeting now.
All right. Have a good night.
Good night.